In this video, we were talking about solving quadratics. This time we're using the quadratic formula. So probably the best thing about the quadratic formula is that it works for every single quadratic. As long as you can write that quadratic in standard form, the quadratic formula will work to solve it. So the quadratic formula, we're just going to get right to it. It solves for x and it gives you both potential answers. So the formula is x equals negative b plus or minus the square root of b squared minus 4 times a times c. Oops, I'm going to separate that a little. And that is all divided by 2 times a. So this is the quadratic formula. This works as long as you have it in standard form. So you need to have ax squared plus bx plus c equals 0 in order to solve using the quadratic formula. So you just take your a, b, and c values and you plug them into the formula. Now, before we get into some examples, I just want to talk about the types of solutions that a quadratic can have. Now, we've already kind of covered this, but just to remind you, you can have two real solutions. And when you have two real solutions, that means that your graph crosses the x-axis 2 times. Now, with two real solutions, I have this written here that b squared minus 4ac is greater than 0. So we'll see why we have that stipulation, why that's true when you have two real solutions. But think about what would happen when you're solving an equation. If your b squared minus 4ac is greater than 0, so let's say that this is all comes out to be 4, right? So this is the square root of 4. Well, that's going to give you your two solutions. So plus or minus the square root of 4 gives you two potential answers there. So if the stuff underneath the radical is bigger than 0, you're going to have two real solutions. Now, instead of calling it the stuff under the radical, b squared minus 4ac is actually called the discriminant. And the discriminant is what determines how many solutions you're going to have. So we talked about if you have two real solutions, your discriminant is bigger than 0. That's what gives you the plus or minus the square root of some number. Now, if you have one real solution, which is a possibility, that means that your graph only touches the x-axis one time. And in that case, your discriminant, b squared minus 4ac, the stuff underneath the radical, is equal to 0. So let's think about that really quickly. If this is the square root of 0, the square root of 0 is just 0. So plus or minus 0 doesn't change anything. So think about if this says plus or minus 0, then that just cancels out and you're left with just simplifying this information. So that only leaves you with one answer. Then you can potentially have no real solution because your graph does not cross the x-axis at all. So notice this graph does not have any x-intercept, so there are no real solutions. Now that's going to happen when your discriminant is less than 0 or when your discriminant is negative. So think about if this is plus or minus the square root of negative 4. Negative 4, you cannot take the square root of that because you cannot take the square root of a negative number. This is not possible. So that's why we have no real solution when your discriminant is less than 0.